we're going to get on to Chapter 2. Chapter 2 is all about matter and change. So I hope that you got a good chuckle from my chemistry pun from our lab equipment days. We learned in Chapter 1 that matter is anything that has mass and takes up a space. So mass, the definition, is a measure of the amount of matter an object contains. Volume is the amount of space occupied by the object. In chemistry, we like to say mass rather than weight, and we'll discuss later why there's a difference. But basically, it has to do with weight factors in gravity and the gravitational pull on the mass. So that's why we use mass in chemistry. It's a measure of how much stuff is in the object. So hopefully you get it like this little picture of Einstein. You are living, you occupy space, you have mass, which means you matter. Some properties of matter. The properties of matter are characteristics that we can use to identify that type of matter. The first property is the extensive property. This depends on the amount of the matter in the sample, so the sample size. So some examples would be the volume of the sample, the mass, or the amount of energy. Remember, when you have to fill in examples, pick a couple to write down. You don't need to write them all, okay? So extensive depends on the amount. Intensive depends on the type that it is, not the amount. It doesn't matter how much you have, as long as it's that same substance, they're going to be the same type of properties. So some examples of intensive would be melting points or boiling points, densities, electrical conductivity. We'll talk about these later on, but these are number values that are assigned to different substances. And that's because no matter how much of the substance you have, it's intensive. Just like we all know, water boils at 212 degrees Fahrenheit or 100 degrees Celsius, and that's something that's going to happen every time that you have pure water. So that is an intensive property because it's water. So the two questions I like to ask myself, because these are kind of hard and they get confusing. Extensive property, since it depends on the amount of the matter in the sample, I like to say the question, how much? It answers the question, how much is there? Intensive depends on the type, so I say what kind. So when you're trying to distinguish between these two, think how much for extensive and what kind for intensive. Substances are, we see substances every day. Matter that has a uniform and definite composition is called a substance. I have pictures here of an aluminum can and a penny. So aluminum and copper are examples of substances. They can also be classified as pure substances, but my pictures are not because pennies are not just pure copper anymore. Aluminum cans have that coating on top. Every sample of a given substance has identical intensive properties because every sample has the same composition. A physical property of a substance is the quality of condition of the substance that can be observed or measured without changing the substance's identity. So we can make physical observations really about, for example, remember just write down a couple, its color. How hard is it? Its hardness. What's the density of it? What does it feel like? What's its texture? What's its smell? Are you allowed to taste it? What's the taste of it? All those kind of things. Is it magnetic? What state of matter is it in? All of those things are physical properties, what we can observe physically about the object. A physical change is a change that alters the substance, but it doesn't change what it actually is. It doesn't change its composition. Physical changes can be reversible or irreversible. So examples of physical changes could be cutting or grinding or mashing or bending or freezing, melting, boiling, any of those. If I took the apple that's up there in the corner and cut it and sliced it, would it still be an apple? Yeah, it just wouldn't be a whole apple anymore. But that's a physical change because it's still an apple. It's still the same composition. It's just in a different form. Keywords to identify physical changes, which is on the next side of your note packet, would be when you see the words boil or freeze or melt, condense, break, cut, split, grind, and crush. Pick a couple, write them down, and you are good. We have states matter. We've been learning about this since you were in elementary school, but a solid is our first type, and that has a definite volume and a definite shape. A solid is a solid. It has that definite shape, has a definite volume, how much your sample is. Liquid has a definite volume, like we could say we have a liter of water, whatever, we have that definite volume, but it's indefinite shaped, meaning it takes the shape of its container. And a gas is indefinite for both because it takes both the volume and the shape of its container. So we could take the gas from the room and condense it down into a smaller container, but we don't know exactly how much gas is in there, okay? So a gas can be compressed like that. A vapor describes the gaseous state of a substance that is generally a liquid or solid at room temperature. So the most common example we have is water vapor. We will normally at room temperature see water being a liquid, but in the air there are water vapor particles, and so that's a way to see a gaseous state. So with our 3 states of matter, I have this wonderful picture here about how we can depict how the different properties of the states of matter are. In your notes I put those circles for you to draw, so go ahead and fill in your own artistic rendition of what a solid, a liquid, and a gas would look like inside a closed container. If you need more time, either pause or yell at me to pause the video. Chemical properties. A chemical property is different than a physical property because it's the ability of a substance to undergo a specific chemical change. So we are changing its composition now. So some examples of chemical properties would be flammability. How flammable is something? Chemical reactivity. How reactive is it? Is it going to react right away? Is it going to take a long time to react? Something like that. A chemical change is where one or more substances are converted into different substances. This occurs during a chemical reaction. So some everyday examples that we see are burning, rusting, tarnishing. Like you might hear somebody say, oh, we need to polish the silver so it doesn't tarnish. Or rusting. I have this picture of this car here. That's a chemical reaction. It's changing the composition. It's not the same substance it was when it was first manufactured. The car has changed. And so that would be a chemical change. We have chemical reactions with these chemical changes occurring, and we have a couple words that you need to know for the whole entire year, okay? Don't forget this. Reactants are the starting substances in a chemical reaction, and products are the new substances formed. So when we write a chemical reaction, what you start with are the reactants. And notice how the reactants are on the left side of the arrow. So make a big note about that because you're going to have to fill this in on the test. I'm not going to give you any hints. Okay, so reactants are on the left side of the arrow. It's what you start with. And then the products are on the right side, what the arrow is pointing to. And that is what comes new, what's formed from the chemical reaction. Products are different than the reactants. So this example is how you can form water, which hopefully you know water is H2O. If you didn't, that's okay. But we take hydrogen and oxygen to form our water molecules. So reactants, left, products, right. Do not forget it. And we are going to stop here for video 1 of chapter 2. At this point in our chapter 1-2 review packet, we can stop and do numbers 23 through 27.